we will see Cayley, Hamilton theorem. We will see Cayley Hamilton theorem. Let us consider A is n by n matrix, then lambda I minus A, it is equals to, then we can write lambda I minus A, it is equals to lambda raised to n plus A1 lambda raised to n minus 1 plus so on plus a n minus 1 into lambda plus a n, it is equals to 0, plus a n, it is equals to 0. That we know lambda I minus a, that is the equation we always equals to the 0. So my characteristics equation becomes lambda raised to n plus a1 lambda raised to power n minus 1 so on plus a n minus 1 into lambda plus a n, it is equals to 0. Cayley Hamilton theorem state that matrix A satisfy its characteristics equation, then this equation lambda raised to n plus a1 into lambda raised to n minus 1 plus so on plus a n minus 1 into lambda plus a n, it is equals to 0. So that means this equation must be satisfied by matrix A. So we can write a raised to n plus, this is a1 as it is, and lambda we will replace by a n minus 1 plus so on plus this a n minus 1 as it is, this lambda becomes a plus this a n is constant, so we will write down a n multiplied by I. Now here we will write down I because this a in the equation, this a raised to n plus a raised to n minus 1 plus so on a, it is equals to a n plus I, it is equals to 0. Here we have taken I because all these a are a matrix, and this is the constant. So this constant now we have converted into the matrix form by multiplying this with the I. I is the identity matrix, that is in a diagonal form there is a 1 1 1 and all rest of the elements are 0 0 0. So this is my identity matrix, and this identity matrix is multiplied by a n, whatever the constant is there in the equation, that we will multiply, and then if it satisfies, it is equals to 0. So we can say that A is satisfied the Cayley Hamilton's theorem. A satisfies the Cayley Hamilton's theorem. Now see here, this is my equation A. This is very important because in these equations we will put the value of the A. And if my value is coming 0, then we can say that my A satisfies the Cayley Hamilton theorem. It says that it satisfies the Cayley Hamilton theorem. Now we will not go for any proof or something like this one. We will directly go for the example. Now see here, in the example we will see that in the example show that matrix A it is equals to 104 then 0 to 0, then it is 3 1 minus 3. 3 1 minus 3 satisfy Cayley-Hamilton theorem. Satisfy Cayley-Hamilton theorem. Now see here, the matrix A is given and we have to prove that it satisfies the Cayley-Hamilton theorem. Now in the solution, first we will find out lambda I minus A, it is equals to 0. So we can write down lambda I minus A, it is equals to, this is lambda I, this is a 3 by 3 matrix, so we have lambda 0 0 0 lambda 0 0 0 and 0. This is also a 3 by 3 matrix, lambda I. So lambda 0 0 0 lambda 0 0 0 lambda, whatever the dimension of the A or the order of the A, the same will be the order of lambda into I minus, then we will write down the A, that is 1 0 4 0 2 0, then 3 1 minus 3 3 1 minus 3. So this is my lambda I, it is equals to 0. Lambda I minus A, it is equals to 0. So this is my lambda I and this is my A. Now we will find out lambda I minus A, it is equals to, we will perform the subtraction, lambda minus 1, so here is the lambda minus 1, this is 0 minus 0, so here is the 0, this is 0 minus 4, so this becomes minus 4, this is 0 minus 0, so this becomes 0, this is lambda minus 2, so this becomes lambda minus 2, and this is 0 minus 0, so here is the 0, this is 0 minus 3, so this becomes minus 3, this is 0 minus 1, so this becomes minus 1, and this is lambda minus 3, so this becomes lambda plus 3, it is equals to 0. It is equals to 0. Now we will expand this one. This lambda I minus A, this equation that we have, the determinant we have, and we will solve this one. So we will write down lambda I minus A, it is equals to, now we will take this lambda minus 1 in bracket, this is lambda minus 2, this is lambda minus 3, and this is 0, so we will write down here. So this is 0, so we multiply anything with the 0, so that becomes 0, so we will take as it is, and here it is minus 4 multiplied by this is 0, and this is minus plus 3, this is minus plus 3, and this is lambda minus 2, and this is lambda minus 2. Now see here we have lambda minus 1 multiplied by lambda minus 2 multiplied by lambda minus 3, and then this is minus 12 multiplied by lambda minus 2 multiplied by 4 into 3, that is minus 12, and this is minus lambda minus 2 as it is, so we have this one. So lambda minus 2, that we can take it outside, so we can have lambda minus 2 outside, and here we have lambda minus 1 multiplied by lambda minus 3 minus 12. This lambda minus 2 and lambda minus 2, that we have taken it outside, so here is the minus 12 only, and here is lambda minus 1 and lambda minus 3 as it is. So we can write down it is equals to lambda minus 2 in bracket, we will expand this one, so sorry, here is the plus 3 now, so here is the plus 3, here is the plus 3, and here is also plus 3. So if we expand this one, then this becomes lambda square, this is 3 minus 1, that is 2 lambda, and minus 3, and here it is minus 12, it is equals to 0. This is equals to 0, this is equals to 0, here is the 0 0, so here is also 0. Okay, now we know this one, so this is equals to lambda minus 2 in bracket, this is lambda square plus 2 lambda minus 15, it is equals to 0. It is equals to 0. Okay. So now after solving these ones, it comes lambda cube minus 7 lambda minus 7 lambda and minus this 30 plus 30, it is equals to this is 4 lambda and this is 15 lambda. That means it is 19 lambda. It is 19 lambda plus 30, it is equals to 0. It is equals to, if we solve this one, if we this multiplied by this lambda minus 2, so it comes lambda cube minus 19 lambda plus 30, it is equals to 0. So this is my characteristics equation. Let's say this equation is A. Equation is A. So characteristics equation, lambda cube minus 19 lambda plus 30, it is equals to 0. This is my characteristics equation. Now substitute lambda, it is equals to A in equation B. In equation B. Now we can have A cube minus 19A plus 30, it is equals to 0. It is equals to 0. So this is my equation. This is my equation. Let's say this equation is C. Let's say this equation is C. Now in this equation A is given, but A cube is not known. So first we will find out what is A cube. Now first we will find out A into A, it is equals to A square. A into A, it is equals to A square. Now A into A is, we have to multiply 104, 0 to 0 and 3 1 minus 3 to the same 104, 0 to 0 and 3 1 minus 3. A into A, this is A, this is A. So we have to multiply these two matrices. These two. So A square, it is equals to. So A square, it is equals to. Now first row and first column. 1 into 1, that is 1, plus 0 into 0, that is 0, and 4 into 3, that is 12. 12 plus 1, that is 13. That is 13. Now 1 into 0, 0 into 2, that is 0, 0, and 4 into 1, so that is 4. That is 4. Now 1 into 4, 0 into 0, 1 into 4, that is 4, 0 into 0 is 0, so this 4 and this 4 into minus 3, so that is minus 12. Minus 12 plus 4, that is minus 8. That is minus 8. That is minus 8. Now the second row and the first column. 0 into 0, 2 into 0 and 0 into 0. So here is the 0. So here is the 0. Now 0 into 0, 2 into 2, that is 4, and 0 into 1, that is 0. So 2 into 2, that is 4. So again we have here 4, and 0 into 0, 2 into 0 and 0 into 0. So we have here 0. So now third column and first row. 3 into 1, that is 3, 1 into 0, that is 0, minus 3 multiplied by 3, that is minus 9, minus 9 plus 3, minus 9 plus 3, that is minus 6. Then 3 into 0, that is 0, 1 into 2, that is 2, 1 into minus 3 into 1, that is minus 3, minus 3 plus 2, that is minus 1. That is minus 1, and 3 into 4, that is 12. 3 into 4, that is 12. 3 into 4, that is 12. 1 into 0, that is 0. Minus 3 into minus 3, that is 9. So 12 plus 9, that is 21. So this becomes 21. So this is my A square. This is my A square. Now we required here A cube. We required here A cube. A cube, it is equals to A square into A. It is equals to A square into A. Now A square is 13 4 minus 8. 13 4 minus 8 multiplied by what is there? 0 4 0 0 4 0 and then minus 6 minus 1 21 minus 6 minus 1 21 multiplied by a. A is what? 104 0 2 0 104 0 2 0 and 3 1 minus 3 and 3 1 minus 3 3 1 minus 3. Now this we have. Now we will find out a cube. A cube it is equals to a cube it is. Now first row and first column. 1 into 13 that is 13, 4 into 0 that is 0 and minus 8 into 3 that is minus 24. Minus 24 plus 13. So minus 24 plus 13 that is minus 11. So here we have minus 11. Now 13 into 0 that is 0. 13 into 4 into 2 that is 8 and minus 8 into minus 8 into 1 that is minus 8. Minus 8 plus 8. So this becomes 0. 13 into 4 that is 52. 4 into 0 0 minus 8 into minus 3 that is 24. 24 plus 52. 24 plus 52 that is 76. So this becomes 76. So 0 into 0, 4 into 0 and 0 into 0. So here we have 0. So 0 into 0 that is 0, 4 into 2 that is 8 and this is 0 into 1 that is 0. So 4 into 2 that is 8. So here we have 8. So 0 into 4 that is 0. 4 into 0 is 0. 0 into minus 3 that is 0. So we have 0 here. Now again minus 6. Minus 6 into 1 that is minus 6. Minus 1 into 0 that is 0 and 21 into 3 that is 63. 63 minus 6. 63 minus 6 that means it is 57. That is 57. Minus 6 into 0 that is 0. Minus 1 into 2 that is minus 2. Minus 2 plus 21. So that becomes 19. That becomes 19. So here is minus 6 into 4 that is minus 24. Minus 1 into 0 that is 0 and 21 into minus 3 that is 63. 63 plus 24. 63 plus 24 that is 87. So this becomes minus 87. This is minus 24 and this is minus 63. Minus 24 minus 63. So that becomes minus 87. So we have a cube. We have a cube. Now we will put the values. Substitute the values of put a cube a in equation D. In equation C. Here is the C in equation C. Now we can have, see here, this is a cube. So we will write down here a cube first. A cube is minus 11. Here is 0. Here is 76. Here is 0, 8, 0. Then 57, 19, minus 87. Minus 19. This is minus 19 and A is 104, 020. 104, 020 and then 31 minus 3. 31 minus 3. 31 minus 3. This is 19A. This is 19A plus 30. Plus 30. Now this is constant. This is constant. So we will write down here. What is this? Plus or minus? Plus 30 multiplied by I. That is 100, 010, 001. 001. It must be equals to 0. It must be equals to 0. Now see here, we will write down this one. Okay. This is minus 11. This is 0. This is 76. This is 0, 8, 0. And this is 57. This is 19. And this is minus 87. Minus 19. We will multiply the 19 to the each elements of this matrix. So this becomes 19, 0, 19 into 4, that is 76. 19 into 0, 0. 19 into 2, 38. 19 into 0, 0. 19 into 3, 57. 19 into 1, that is 19. And 19 into 3, that is 57. So this becomes minus 57. Plus, we will multiply 30. So 30 into 1, that is 30. 0, 0, 0, 30, 0, 0, 0, 30. Because all these are elements 0, 0, so here is the 0, 0, and 1 multiplied by 30. So that means diagonally we have 30, 30, 30. Now we will do the addition of this one. So now it is equals to, see there, what is coming here now? So what is coming here? This is minus 11, this is minus 19, and this is plus 30. Okay, this is 0 minus 0 plus 0, 0 minus 0 plus 0, and this is 76, this is minus 76, and this is plus 0. Okay, this is 0 minus 0, okay, and plus 0. 8 minus 38, 8 minus 38, and this is plus 30. Okay, this is 0 minus 0 plus 0, 0 minus 0 plus 0. This is 57, this is minus 57, and this is plus 0. This is 19, and then minus 19, and here is the plus 0. So here is plus 0. This is minus 87, minus 57, minus plus, minus plus 57, and then here is plus 30, so it is equals to minus 11 minus 19, that is minus 30 plus 30. So here we have 0, 0 minus 0 plus 0 is 0. 76 minus 76 is 0. 0 minus 0 plus 0 is again 0. 0 minus 38, that minus 30 plus 30, that becomes 0. 0 minus 0 plus 0 is 0. Minus 57 plus 57 is 0. So here is 0. Plus 19 minus 19 is 0. And minus 87 plus 57, that is minus 30 plus 30 becomes 0. So it is coming 0. Hence A satisfy Cayley Hamilton theorem. It must be 0. So this characteristics equation, that is a cube minus 19a plus 30, it must be equals to 0. So our answer must be 0, and it is coming 0, So we can say that our given matrix A satisfy the Cayley Hamilton theorem.